Okey, Assalamualaikum dan salam sejahtera. Alright, kita ada kuliah ringkas sedikit, last lecture for this semester. Okey, saya akan share berkenaan dengan adsorptive stripping voltammetry. Okey, kita dah discuss banyak metod-metod dalam voltammetry. Ada cyclic voltammetry, anodic stripping voltammetry, pulse voltammetry, kan ada polarography. Instead of voltammetry ada polarography dan sebagainya. Okay, sekarang kita tengok apa tu adsorptive stripping voltammetry a little bit. Nama ringkasan dia ADSV. ADSV. It's similar to anodic stripping voltammetry and cathodic stripping voltammetry, except that the pre-concentration step is not controlled by electrolysis. Okay, kalau kita tengok anodic stripping and also cathodic stripping voltammetry, the pre-concentration step, okay, before we strip all the analyte, cation or anion, we control it by electrolysis, different charge. Okay, remember kalau analyte kita tu negative charge, okay, so we do cathodic stripping kan, kita bagi positive charge dulu, so all the analyte akan pre-concentration step akan bulk dekat electrode, okay, akan jadi amalgam, and then we strip, okay, and then measurement happen there. Untuk adsorptive stripping voltammetry, the pre-concentration step tidak berlaku dengan electrolysis, tetapi the pre-concentration step in adsorptive stripping voltammetry is accomplished by adsorption on the working electrode surface or by reaction with the chemically modified electrodes. Dia pre-concentration step tu, kita punya analyte adsorb pada working electrode surface, okay, melalui reaction dengan electrode surface tu dan juga chemically modified electrode tu lah yang dah diubah suai supaya kita punya analyte adsorb, okay, terjerap pada permukaan electrode. Okay, next. Okay, so it's consist of 3 steps. Okay, step 1, deposition or adsorption. For example, kita ada a complex nickel DMG, okay, nickel DMG molecule. Okay, and then deposition, okay, adsorb pada permukaan nickel DMG, adsorb pada permukaan electrode. And step 2, quiet time. Okay, ada quiet time sekejap. Okay, mana biar sekejap dia quiet time ni biasanya a few second lah, kita biar keadaan reda. Okay, after the deposition, kalau dalam anodic or cathodic stripping, after the pre-concentration step. Okay, and then the stripping process, similar to anodic and cathodic stripping process. Okay, so what is DMG? DMG is the dimethyl glyoxime, yang complex agent yang untuk nickel, special untuk nickel kan. Kita belajar gravimetric method kan. Ada. Alright, so apa kalau kita tengok kita dah belajar polarography dan juga voltammetry. Apa advantage of voltammetry? No problem with high ion concentration, low detection limit, okay. Automation, kita boleh letak 80 sample plus all buffer and standard, and simultaneous detection of metal. Kita boleh yang famous kita simultaneously detect 4 metal plumbum, cadmium, copper and MS1, and calibration in every run, variable standard addition if required. Maknanya kita boleh calibrate in every run, okay, dengan menggunakan standard addition method. Okay, kita ada juga quantitative analysis ataupun dipanggil sebagai the Ilkovic equation. Okay, kita measure diffusion current, diffusion current, relate with the diffusion current, the concentration of the analyte and the characteristic of the mercury drop. Okay, so ID ataupun diffusion current ni, itu formulanya, di mana ID adalah maximum value of the diffusion current in the life of the drop. Maximum value of the diffusion current in the life of the drop. N is number of electron involved. C is concentration of ion in bulk. okay, or millimole per liter, and D is diffusion coefficient of the ion. Okay, it is temperature dependent, and M is the flow rate of the mercury in mg per second. Okay, T is a drop life in second. So Ilkov equation is applicable in the given form only if the migration of the analyte ions, the mass transport berlaku dalam keadaan migration of ion due to the electric field. Maknanya migration migration, remember migration macam mana? Different charge. Okay. And is suppressed by addition of inert supporting electrolyte, usually 1 molar of KCl. In this case, diffusion remains essentially the only kind of mass transport of the analyte ions in the redox process. Okay, in this case, diffusion remains essentially the only kind of mass transport. Okay, remember tadi Ilkov equation is applicable in the given form only if the migration of the analyte ion, transport of ion due to the electric field is suppressed. Okay, macam suppress kita dah belajar macam mana suppress migration adalah melalui inert supporting electrolyte. Kita nak biarkan, okay, recall back the Nernst-Planck equation, kita nak only diffusion happen. So also unstirred condition, unstirred solution, okay, no convection current. Kita hanya biarkan diffusion berlaku. Okay, furthermore, the supporting electrolyte enhance conductivity of the solution. The supporting electrolyte may also contain buffer to adjust the pH at a suitable value and chelating agent to mask the interfering ions. Okay. Calibration method. Ni dah calibration method dalam voltammetry. Okay. In this case, kita buat tadilah. Kita kira apa nama ni? Diffusion current tadi. Okay. ID. Okay. A polarographic run is carried out separately for each standard solution and the diffusion current is calculated. Okay. Tengok tu dia increase the concentration of iron 2, okay, from 20 millimolar to 60 millimolar. Then the diffusion current is calculated from this. Okay, ini 20 millimolar. Okay, 30, sorry, tarik atas sikit mula. Ini adalah 20 millimolar, 30, okay, 40, 50 dan 60 kan. Makin meningkat. So kita plot lah. Okay. Tengok di sini tengok current density dia tu negative value. Okay. So sini pun kalau plot kita pun negative value lah. Okay, negative value kita plot. Dan macam biasalah calibration, kalau kita ada unknown diffusion current ni kita measure, kita boleh tengok the concentration based on the calibration plot. Okay. Alright. So a working curve of diffusion current against concentration of standard obey Ilkovic equation is plot. Okay, tengok dia meningkat secara linear. Okay, meningkat secara linear. Then kita boleh plot calibration. A separate polarigraphic wave is done for the analyte and the analyte diffusion current is calculated and compared to the calibration curve to get the concentration of the analyte. Maknanya kalau ada unknown, okay, kita just analyze separately. Okay, dan kita measure berapa dia punya current density tu. Okay, density current, ID dia tu. Dan kita boleh tahu berapa concentration dia. Pun juga kita boleh buat standard addition method. Okay, sama macam AAS, okay, alat-alat lain yang ada linear relations between the response and also the concentration. So kita buat standard addition. Despite a small volume of standard solution of known concentration into original volume of sample of known concentration. Of unknown concentration of sample. Ya, macam kita dah belajar, recall balik standard addition, kita prepare a series of calibration solution with increasing concentration, minimum 5 kan, ingat so that kita letakkan a similar volume of sample with unknown concentration dalam setiap known concentration calibration solution kita. Okay. Lepas tu calculate the concentration of the analyte using the Ilkovic equation. Okay. Kita dapat the unknown concentration. Okay. Cu is the concentration of the unknown. In the above equation, we substitute for the diluted concentration of unknown and standard as follow. Okay, so ada diluted tu kena tengok balik lah. Right? So kelebihan polarografi can be used for determination of many inorganic ions that can be reduced in the range of plus 0.4 to negative 1.2 volt. Mainly most of the transition metals, lanthanides and actinides can be determined by polarography and also used to quantitatively analyze a wide variety of electroactive organic functional group. Okay, and it's possible to analyze simultaneously a mixture of 3 to 4 electroactive ions, macam metal juga. Okay, untuk organic functional group pun kita boleh measure 3 to 4 simultaneously. Itu kelebihan polarografi and also voltammetry. Okay, alright, sebenarnya tak panjang lecture saya hari ni. Sekejap saja nak recall ataupun nak tambah adsorptive stripping voltammetry dan juga Ilkovic equation. Okay, kita boleh buat, kita boleh plot calibration sama linear calibration. Okay, itu standard calibration dan juga standard addition okay, of calibration. Okay, standard addition method dan juga calibration curve biasalah dua ni kita boleh buat dengan mengira current density. Okay, that's all. Our short lecture. Thank you so much, guys, for your commitment, for your for your effort in this course, SSCC 4233, analytical electrochemistry with me for the whole semester. I appreciate your effort, okay, to learn with me, to participate in all activities, and please always remember me, okay, when you meet me, say hi to me, okay, because I cannot recognize, maybe I cannot recognize all of you, but I can recognize actually almost all of you because I have been teaching you since your first year. So I know I can recognize your familiar faces. And then, after this, you have only one semester more to finish your study, and you are a big guy, okay, big person now after graduate. Please always remember UTM and Faculty of Science and Department of Chemistry. All right.